In this section, we're going to solve systems of two equations in two variables using the addition method, sometimes also referred to as the elimination method. And as I mentioned at the end of the previous section video, this is a very important technique because when we get to the point where we're solving systems of three equations with three variables, you won't be able to complete those problems or solve those systems without the technique that we're going to look at in this section. So let's have a look. There is a step-by-step list provided for you here if you want to check that out. Some of us like to see all of those steps, some of us not so much. They're kind of intimidating. I will leave it up to you if you want to read that. I'm going to jump right in like Sophie just... Ow, right over what am I, a bridge? Thanks a lot. She likes to chew on the wires. Can you blame her? I want to jump right in and solve one of these systems using the elimination or addition method. She also really likes caps. Let's see if she'll just follow this thing. Oh yeah, went right after it. In order to solve using the addition or elimination method, it's nice if you have everything kind of line up. So if you notice in this first system of equations, I see my y terms are lined up here, but the next thing that happens is I've got an equal sign and I've got my x terms. I don't like that. That's not going to make this process very easy. Now this system of equations is actually perfectly set up to solve using substitution. However, we want to practice solving by elimination or addition. So I'm going to move some things around. I'm going to add 3x to both sides of equation number 1 so that I get y plus 3x equals 13. So that's equation number 1. And now we're going to really going to sort of focus on this system here. And the idea of the addition or elimination process is we're going to modify one or both of these equations so that when we add them together, literally add the two equations together, one of our variable terms is going to cancel out. I'll show you. I'm going to rewrite equation number 2. And if you're taking notes on lined paper, I would highly recommend leaving a blank line right in here. Oh, how about that? She brought the cat back. You are a good cat. Go get it again. Good girl. Leave that blank line there. It's going to help you see the progress that we make on this system of equations. All right, so I skipped a line, I rewrote equation number 2. Now I'm going to take equation number 1 and I'm going to multiply the entire equation by -9, which gives us negative 9y minus 27x equals, and then 13 times 9. That's 13 times 9 again. We just saw that recently. I think it was in the previous video. Is going to be negative 117. And that's equation number 1 having already been multiplied by -9. Now what am I going to do? Notice these are opposites, -9 and +9y. So what I'm going to do is I'm going to add these two equations together. 9y plus -9y cancels out. 2x plus -27x is -25x, and -8 plus -117, -8 plus -117, there we go, equals -125. This is so strange to be seeing these numbers again. And then now that we've got this, I'm going to divide both sides by -25. Divide by -25 to get an x value of 5. And now we can take this x value of 5 and plug it back into either one of the two original equations in order to solve for y. Which of the two original equations do you think we should plug our x value back into? I think since we're solving for y, we should plug it back into the first equation since it says y equals. So I'm going to substitute that x value of 5 into equation 1, which says now that y equals 13 minus 3 times 5. And 13 minus 5 is negative 2. So we have our y value, and we can present our solution as an ordered pair. X comma y equals 5, negative 2. I have to believe that this was the same system that we worked in the previous section in 3.2. We solved it using substitution that time, and this time we're solving it using elimination. So I'd like to solve this system also. I don't really want to solve it. Nobody wants to solve this system, of course. And, oh, has the iPad finally had enough of me? I think this is my like 10th video that I'm making today. One of the things I won't miss about 2020 is making like 12 videos a week. Not that I don't care about you and want you to have high quality videos, but man, oh man, it's a lot. It's an extra like 20 hours a week. It's like a new part-time job. Not complaining. Very grateful, to be honest. Let's see. So the unfortunate part about this system of equations is that it involves fractions. I don't really want to have to work with fractions. I'm thinking that maybe the first thing I'll do is multiply each of these equations by a number that's large enough that it'll cancel out all of my fractions. And then I'll see where we're going to go from there. So let's number these 1 and 2. I'm going to multiply equation number 1 by 6, which gives me 2x minus 3y equals 12. That looks much nicer already. That's equation number 1 times 6. Equation number 2 I'm going to multiply by 4. That's 4x plus y equals 10. Also much nicer. That's equation 2 times 4. Just double checking my arithmetic. I think that's okay. And so now we'll think of this as a new system. What modification do we need to make from here so that when we add these things together, something will cancel out? These numbers are pretty convenient. We could take the 2 in front of the x, multiply that equation by negative 2, which would make it negative 4x, which would cancel out with the positive 4x. The other option is, I love when I have a variable with a coefficient of 1 or negative 1, because I can easily make that into whatever I need it to be. In this case, I would take equation 2 and multiply it by 3 so that that becomes a positive 3y, which will cancel out with the negative 3y above it. And in fact, I think that's what I'm going to do. Let me take equation number 1 and rewrite it. 2x minus 3y equals 12. Still labeling that as equation 1. And then I'm going to take equation 2, or this modified version of equation 2, and multiply it by negative 3. So we get negative 12x minus, oh wait, don't multiply it by negative 3, multiply it by positive 3, sorry. So that says positive 12x, yep, plus 3y equals, don't forget to multiply the right-hand side by 3, so that becomes a 30. That's equation 2. We multiplied it by 3 that time. Another technique that you could do to help keep your, make sure that you do all of your multiplication correctly, instead of using this kind of notation, you could also use some arrows and draw an arrow down to here and write times 3. The problem is maybe when you have to can't even talk anymore. When you have to modify both equations, if we were modifying this one and maybe multiplying it by 1/2 or something, all of a sudden you end up with a lot of arrows. So devise whatever technique you think is going to work best for you. She's back. She wants it. She's got a lot of energy. She's like 11 months old. Okay, so now we're set up to add these two equations together. Right, so I was saying use whatever kind of notation you want in order to keep track of the modifications that you're making as you modify these equations to set them up to add together. We can add together now because the negative 3y and positive 3y are going to cancel each other out, leaving us with 14x and 42. And if we divide both sides of that equation by 14, we get an x value of 3. I love it when it works out like that and I get a nice round number. Why she has to keep bringing my cap up here and playing with it up here, I don't know. Are you having a good time, Sophie? Now we can take our x value of 3 and plug it back into one of our original equations, or maybe we want to plug it into one of our modified equations. We're going to be solving for y, so I'm thinking that maybe this is the best equation to plug it back into, since that equation has a positive 1y in it. So I'm going to put a star next to that equation, and I'm going to say sub into star. Oof, that star wasn't so good, but I'm stuck with it. Okay, so we have 4x plus, no we don't. We have 4 times our new x value of 3 plus y equals 10. That's our starred equation. And I'm right at the bottom of a page here, so I'm going to go horizontally and say that I'm going to subtract 12 from both sides in order to get my y value of negative 2. And we can present our final answer, our solution, as an xy ordered pair, which is 3, negative 2. So I hope that you're seeing the sort of game of all of this, which is modifying using multiplication or potentially division, or maybe even just moving things around within one, you can't see my hands moving, moving things around within one equation in order to get things to line up, and then using multiplication or division so that two terms that are above and below each other are opposite one another. So we've got a negative 3y and a positive 3y here, those added together and canceled out. In the previous problem, we had a positive 9y and a negative 9y. Those added together and canceled out, giving us one equation with one variable. That's easy to solve. Here they canceled and we ended up with one equation and one variable. You can eliminate your x value or your x terms, or you can eliminate your y terms, whichever one's most convenient. I highly recommend keeping an eye out for a term that has a coefficient of 1, again, because it's so easy to modify that and turn it into whatever you need to turn it into so that terms cancel when you add your equations together. There are some other example problems that I could show you here, but it's going to get a little redundant. We just need to keep moving things around and prepping so that we can do this addition process and have terms cancel out. Is it possible that solving a system of equations is going to result in something right here that says 3 equals 3? Probably not, because I always set things up so I've got all my variables on the left and my constant values on the right hand side of the equal sign. So we're not going to end up with something like 5 equals 3. But what you could end up with is if everything on the left hand side cancels out, you could end up with a 0 on the left hand side and a 3 on the right hand side. And we already know that 0 never equals 3. So if that happens, you're probably looking at a system that has no solution, which means you've got parallel lines. Again, something like 0 equals 3 indicates no solution. Or maybe it's telling you that you've made an arithmetic mistake. Unfortunately, that's always a possibility. You don't want to have to do any one of these problems more than once. So make sure that you take it slow, stay organized, sharp pencil, skip a line between each pair of the system of equations that you're modifying. Make it look as presentable as possible. As bad as my handwriting is, you can see that I am trying to keep things organized here. I recommend that you do the same. Number your equations or label them however you want to. Letters, numbers, I don't care. The other possibility is that when you do this addition process, that everything might cancel and you get 0 equals 0. How often does 0 equal 0? All the time. Doesn't matter what your input values are. So if you get something like 0 equals 0, which in the case of the addition process, that's what you would get. That indicates that you have infinitely many solutions. And you've already seen in the previous section video how to present an answer when you have infinitely many solutions. So this addition process could deliver you to a individual unique solution like 3, -2, or you could arrive at something contradictory like 0 equals 3, which is inconsistent. There are no solutions. Or you could end up with 0 equals 0, which is consistent but dependent, because it means that your two equations describe the same line and you have infinitely many solutions. All right, those are the three scenarios. This was a different way to solve the system of equations. A reminder, get good at this because we're going to see it again real soon. I'll see you real soon in the next section. Thanks so much.